Welcome to this essential guide on laboratory safety, focusing specifically on working safely with chemicals. Chemical safety is the foundation of all laboratory work in chemistry. Whether you're a student beginning your first chemistry course or preparing for advanced laboratory techniques, understanding how to handle chemicals properly can prevent accidents, protect your health, and ensure a productive learning environment. This video is part of our Lab Techniques series, designed to build your practical skills in the chemistry laboratory. Throughout this presentation, we'll cover the critical safety practices that every chemist must know, from personal protective equipment to emergency procedures. Let's begin our journey toward becoming safe and confident laboratory practitioners. Personal protective equipment, commonly abbreviated as PPE, forms your first line of defense against chemical hazards in the laboratory. Safety goggles are essential for protecting your eyes from chemical splashes and harmful fumes. Unlike regular glasses, safety goggles provide a complete seal around your eyes. A lab coat shields your skin and clothing from accidental spills and splashes, creating a barrier between you and potentially harmful substances. Chemical-resistant gloves are critical, but it's important to choose the appropriate glove material based on the specific chemicals you're handling. Different materials protect against different substances. Finally, always wear closed-toe shoes in the laboratory to prevent exposure if chemicals spill on the floor. Sandals, flip-flops, or any open footwear should never be worn in a chemistry lab. Remember, wearing proper PPE is not optional. It's a fundamental requirement for laboratory safety. Understanding chemical hazard classifications helps you recognize potential dangers before you begin working with any substance. Flammable chemicals, such as solvents, alcohols, and acetone, can easily ignite and must be kept away from heat sources and open flames. Corrosive chemicals include strong acids, bases, and oxidizing agents that can cause severe burns to skin and damage to materials. Toxic chemicals, including heavy metals and cyanide compounds, can cause serious health effects even in small amounts and require special handling precautions. Reactive chemicals, such as peroxides and alkali metals, can undergo dangerous reactions, sometimes explosively, when exposed to water, air, or other substances. Irritant chemicals like ammonia and formaldehyde can cause discomfort and damage to skin, eyes, and respiratory systems upon contact. Finally, temperature-sensitive chemicals, including cryogenic liquids and thermolabile compounds, require specific storage conditions to remain stable. Always identify the hazard class of any chemical before use. Safety data sheets, known as SDS, are comprehensive documents that provide crucial information about chemical hazards and safe handling procedures. Every chemical in the laboratory should have an accompanying SDS that you can access easily. While SDS documents contain 16 sections, 3 sections are particularly important for laboratory safety. Section 2, Hazard Identification, describes the physical hazards, health hazards, and environmental hazards associated with the chemical. This section uses standardized hazard symbols and warning statements. Section 4, First Aid Measures, provides critical emergency response information for different types of exposure, including inhalation, skin contact, eye contact, and ingestion. This information can be life-saving in an emergency. Section 8, Exposure Controls, specifies the personal protective equipment requirements and lists exposure limits that indicate safe concentration levels. Before working with any new chemical, make it a habit to review its SDS to understand the specific risks and necessary precautions. Proper chemical storage is essential for maintaining laboratory safety and preventing accidents. All chemical containers must have clear labeling that includes the complete chemical name, concentration, date received, and date opened. Hazard warnings should be clearly visible on every container. Understanding chemical incompatibilities is crucial for safe storage. Acids must be stored separately from bases because mixing them can generate dangerous heat and splatter. Oxidizing chemicals should be kept away from flammable materials to prevent fire hazards. Organize your storage area by hazard class, keeping similar types of chemicals together. The storage environment matters significantly. Chemicals should be kept in cool, dry, well-ventilated areas away from direct sunlight, which can degrade many substances or increase pressure in sealed containers. Use secondary containment, such as trays or bins, under liquid containers to catch any leaks or spills. When organizing shelves, store chemicals at or below eye level for easy access and visibility. Place heavier containers on lower shelves to prevent injuries if they fall. Conduct regular inventory checks to identify expired chemicals or damaged containers that need attention. Following proper handling techniques significantly reduces the risk of accidents when working with chemicals. Never smell chemicals directly by placing your nose over the container. If you must detect an odor for identification purposes, use the wafting technique by gently waving your hand over the container toward your nose. Always work with volatile, toxic, or strong-smelling chemicals inside a fume hood, which provides ventilation to protect you from harmful vapors. When diluting acids, remember this critical safety rule: always add acid to water, never water to acid. Adding water to concentrated acid generates intense heat that can cause the mixture to boil violently and splash. Use only the minimum quantity of chemicals necessary for your experiment. This practice reduces waste, minimizes exposure, and makes cleanup easier. Keep container lids securely closed when not actively using the chemical to prevent evaporation, contamination, and accidental spills. If a spill occurs or you notice any contamination, clean it up immediately rather than leaving it for later. Prompt action prevents the spread of contamination and reduces exposure time. Knowing how to respond to chemical spills can prevent small incidents from becoming major emergencies. Follow these 5 steps for effective spill response. Step 1. Immediately alert others in the laboratory area about the spill. If the spill involves a highly toxic or volatile chemical, or if it's too large to handle safely, evacuate the area and call for professional help. Step 2. Before approaching any spill, put on appropriate personal protective equipment. At minimum, wear safety goggles, gloves, and a lab coat. For larger spills or more hazardous materials, additional protection may be necessary. Step 3. Contain the spill to prevent it from spreading. Use absorbent materials such as spill pads, sand, or commercial absorbents to create a barrier around the spill perimeter. Work from the outer edges toward the center. Step 4. Clean up the spill using materials from your laboratory's spill kit. Carefully collect the contaminated absorbent materials and place them in appropriate waste containers. Never use your bare hands, even while wearing gloves, to pick up broken glass or sharp objects. Step 5. Document the incident by recording what chemicals spilled, the approximate quantity, how it was cleaned up, and who was involved. Notify your supervisor or laboratory instructor about any spill, regardless of size. Proper chemical waste disposal protects both human health and the environment. Never dispose of hazardous chemicals down the drain, as this can contaminate water supplies and harm aquatic ecosystems. Waste segregation is the first principle of proper disposal. Separate waste by category, such as organic solvents, acids, bases, and heavy metals. Never mix incompatible wastes, as chemical reactions in waste containers can generate heat, toxic gases, or even explosions. Use only designated waste containers provided by your institution for chemical disposal. Each waste container must be properly labeled with complete information. List all chemical contents in the container, even if multiple substances are present. Include hazard information so anyone handling the waste understands the risks. Write the date when you first added waste to the container, as there are often time limits for how long waste can be stored. Container management requires attention to safety details. Keep waste container lids closed at all times, except when actively adding waste. This prevents evaporation, reduces odors, and minimizes the risk of spills. Store waste containers in a designated area away from active workspaces. Schedule regular pickups with your institution's environmental health and safety department to ensure waste doesn't accumulate beyond safe limits. Familiarity with emergency equipment and procedures is essential for every laboratory worker. The safety shower is designed for large chemical spills affecting significant portions of your body or clothing. If chemicals soak through your clothing, immediately go to the safety shower, pull the handle, and rinse for at least 15 minutes while removing contaminated clothing. The eye wash station provides continuous water flow to flush chemical splashes from your eyes. If any chemical contacts your eyes, go immediately to the eye wash station and flush for a full 15 minutes, holding your eyelids open to ensure thorough rinsing. Fire extinguishers in chemistry laboratories are typically rated for multiple types of fires. Know where the nearest fire extinguisher is located and learn how to use it properly before an emergency occurs. The fire alarm should be activated immediately if a fire grows beyond what you can safely control with a fire extinguisher. Emergency contact numbers for campus security, environmental health and safety, and poison control should be posted visibly in the laboratory for quick access during emergencies. Finally, know all evacuation routes from your laboratory and the designated assembly point where everyone should gather after evacuating. During fire drills, practice these routes so you can exit quickly and safely in a real emergency. Let's review the most important points from this laboratory safety presentation. First, always wear appropriate personal protective equipment before handling any chemicals. Your safety goggles, lab coat, gloves, and closed-toe shoes are non-negotiable requirements. Second, read and understand the safety data sheet before working with new chemicals. The SDS provides essential information about hazards and safe handling that you need to know in advance. Third, store chemicals properly according to their hazard classifications and label all containers clearly with complete information. Proper storage prevents accidental reactions and makes it easy to identify chemicals quickly. Fourth, know your laboratory's emergency procedures and the locations of all emergency equipment, including safety showers, eye wash stations, fire extinguishers, and exits. In an emergency, this knowledge can save lives. Fifth, dispose of chemical waste according to regulations. Never pour hazardous chemicals down the drain and always use properly labeled waste containers. Remember, safety is everyone's responsibility in the laboratory. By following these practices consistently, you protect not only yourself, but also your colleagues and the environment. Stay safe, stay informed, and always prioritize safety in your laboratory work.
If you like this video, hit that like button and don't forget to subscribe. Visit codelucky.com for more such useful content.